Here's our two functions. Let's figure out from the graph what our a, b, c, and d variables are. The IB doesn't really make you do it this way, but I think it's probably good practice if you can do this backwards. It really shows that you understand the concept. So let's start with A. That's really easy. It's where the demand curve intersects the q-axis, so we can see that that's 30. And then remember, B is going to be the slope. So it's going to be 30 to 0 is the run over a rise of 0 to 10. That looks familiar. But anyway, 30 and 10, that's going to reduce, and this is going to be negative 3p. Remember, we have a negative there because it's always going to be negatively sloped. It's not negative and a negative, so you could have just left off that part there. It's still a run of 30. It doesn't matter whether it was 0 to 30 or 30 back to 0. The run is 30. All right, so we have 30 over 10. So we have the same exact demand function we had on the other, on the previous diagram. Let's see what this is going to be. Well, we see that its c variable is going to be negative. We know this because it has a y-intercept. It doesn't start at 0 or some positive quantity. So we know that's going to be negative, but we can't see what it is going to be, so we'll have to solve for c eventually. We can do d, which again is going to be run over rise. We know it's positive, so our run is a run of 0 to 6, and our rise is a rise of 5 to 8. So 3. So 6 over 3, of course, reduces to 2. So we know that this is positive 2. Now that we know that, again, that looks a little familiar. Now that we know that, we can take this point that we're looking at, 8 and 6, and we can plug that in and solve for c. So we have a quantity of 6 is equal to negative, we'll see if it turns out to be negative. Quantity of 6 is equal to c plus 2 times price of 8. So this is saying 6 is equal to c plus 16 minus 16 minus 16, and we see that c is equal to negative 10. So yes, these are the exact same two functions we saw in the previous diagram, but they don't look the same, do they? I did this to kind of get you ready for where we're going next, which is a study of elasticities. And it's important that you understand the way a demand or supply curve looks doesn't mean a lot. The reason this looks so much different is on the previous diagram, 0 to 30 was about this far. And I've taken it and I've compacted it in. So that has changed the angle that we see for demand and supply. It's still the same information. It hasn't changed what the functions are, and it won't change anything about how you solve them. They just are going to look a little bit different. It's very common, and you need to be aware that that's something, a problem to not let yourself go down. What the curve looks like doesn't dictate what the function is. Okay, as I talk about this, just a quick reminder, the y-axis is p, the q-axis is x. I talk about those kind of interchangeably to remind you of that. Just remember that if I talk about the y-axis or the p-axis, I'm talking about the same thing. The first thing we need to do to graph, once we have our two functions, is we're always just going to go grab the a variable first. A very common step is they're going to have you calculate equilibrium for this. Maybe not always, but it's pretty typical. So since we need 2 points for every line, to draw a straight line, we need 1, 2 for demand, and then we need the y-intercept and equilibrium for supply. So you don't really need to graph 4 because both of them are going to share that equilibrium point. So you can just graph 3, make your lines, and move on. So we need to graph the a variable, we need to graph equilibrium, and then we need to graph the y-intercept here. Or, remember, if the c variable is 0, which then you just won't see it, it'll be gone. Or if it's positive, then we can just go ahead and put that on the q-axis as well. Okay, so the a variable, we've got it there. That's simple. There's no calculation necessary. It's 30 and 0. Next, let's solve for equilibrium. Well, remember, what we're saying is that this equilibrium point is where quantity demanded is equal to quantity supplied, or this function is equal to that function. So we're going to take 30 minus 3p and substitute it here. And we're going to take negative 10 plus 2 and substitute it for QS. Plus 2p, I apologize. Now that we've got this, I think it's pretty simple. You guys can see how it's going to go. We need to get the p's on one side and the 10s on the other. I like to work with positives, so I'm going to take negative 10, add 10 to this side, and add 10 to this side, and then add 3p to each side as well. So we're going to end up with 40 is equal to 5p. Now we need to solve for price. So price is equal to 8. And this isn't price anymore, now it's P star, because it's the price for QD and it's the price for QS. So it's an equilibrium price. We're not quite finished. We know that this is 8, and then we can confirm that up here. But remember, we're actually trying to draw this, so we don't know that yet. So we have our A variable here at 30 and 0. We have our price at 8, but we don't know what the quantity is. So we need to take this, P star equals 8, and mathematically, you really only need to put it into one of these two functions, but the IB is going to want to see you put it into both. Because again, the emphasis is, at this price, the quantity demanded is equal to the quantity supplied. That's our whole drive. So we're going to take 8, and we're going to put it into 30 minus 3p. So let's just go here. Quantity demanded equals 30 minus 3 times 8, or 30 minus 24. Therefore, 30 minus 24, quantity demanded, is equal to 6. We need to do the same with quantity supplied. So negative 10 plus 2 times the price of 8. That's 16, so negative 10 plus 16, of course, is 6. So by doing it twice, you show that quantity supplied is equal to quantity demanded. Regardless, we know the quantity now is 6 at a price of 8, so that's our second point. That's obviously the hardest one to do. Third, again, if we have a positive or a 0, we can just put it on the q-axis, but we don't here. We have a negative c variable, so we need to solve for it. Remember, at the y-intercept, what's happening is quantity is 0 and then price is something positive, but we don't know what yet. So what we can do is we can just put QS equal to 0 into our formula. So we're going to take QS as 0 is then equal to negative 10 plus 2p, and we need to just solve for p. And there we have it. So we can put that third point, P5 quantity 0 on there, and then just graph accordingly. The last thing that you want to be able to see here is once we know all of this, it's also good to see this mathematically over here. So you ought to be able to see that if I take the price of 5 and put it into my quantity supplied formula, quantity supplied equals negative 10 plus 2 times 5 is 10, so quantity supplied is 0. Well, what about quantity demanded? Let's take 5 and put it in here. So quantity demanded equals 30 minus 3 times 5, 15. Therefore, quantity demanded is 15. So if we put the price at 5, what would be the outcome? We would have 0 supplied and 15 demanded. Therefore, we would have excess demand or a shortage. Well, so let's keep moving the price up and see what we find. What if we put price at 6? Well, quantity supplied equals negative 10 plus 2 times p is, or 2 times 6 is 12, so 12 minus 10 is 2. Remember, that's where we see our d coefficient, or our d variable, our coefficient of p. So remember, this is 2 over 1, so we have a rise, 5 to 6 of 1, and then a run of 0 to 2, 2. So it's a run of 2 over a rise of 1, so 2. Likewise here, the same thing. So this is a run of -3 over a rise of 1. So price went up 1, quantity demanded has to decline by 3. So it's going to be 12. So we went from a shortage of 15 to now a shortage of 10, which again it's a difference of 5, so that's the 3 and the 2 added together. Okay, let's prove this one more time and then we'll be finished. So let's take this price of 6 and put it in here. So 30 minus 3 times 6 is 18. 30 minus 18 is, again, like we saw, 12. So in this fashion, we can keep going, and this is just going to increase by 2. So 2, 4, 6, 8, and 10. And then these are going to decrease by 3. So 15, 12, 9, 6, 3, and 0. And again, we can see at 10, that's where 10 in quantity of 0, quantity demanded of 0, that's where we see the demand curve end, 10 with quantity of 0. Also, of course, we can see right here that there's our equilibrium price, where at the same price, quantity supplied is equal to quantity demanded.